In this question, it is given that a liquid flows through a tube of uniform cross-section with a constant speed in the direction as shown by the arrow in figure. The liquid exert on tube. So our aim is to find out whether this is going to exert any force or torque on the tube over here. So just observe this tube over here, and if you are just observing the direction of velocity, initially liquid were flowing along this direction, then the direction of velocity is changed over here, then again over here direction of velocity is changed. So we can find out what about the value of force acting on each corner. Whenever there is a change in magnitude of momentum or direction of momentum, there is a change in or there is a force, because force is rate of change of momentum. So first we can find out at this corner, this is representing the final velocity and this is representing the initial velocity. But if you want to find out the value of acceleration, we'll go for final velocity minus initial velocity. This is the direction of final velocity vector, and this is a direction of like opposite to initial direction of velocity vector. So actual u vector is along this direction, but we are taking v vector minus u vector in the opposite direction. So the resultant force is going to act along this direction. So this is the direction of resultant force over here. Like that, we can find out on the other corner what about the direction of resultant force. This is the direction of final velocity vector. So this is our final velocity vector, direction of final velocity vector. And this was the direction of initial velocity vector, but we need to take in the opposite direction, that is final vector minus initial vector, that is final vector plus negative of initial vector. So if we are adding these two, we are going to get the force which is acting along this direction. This is the direction of force over here, or this is the direction of force over here. Overall, we can say that for a structure something like this, when liquid is flowing through it, the direction of net force or the force exerted by the over here we just observe the force exerted by the tube on the liquid, because we consider the change in momentum or change in velocity of liquid. So force exerted by the container, by the tube on the liquid, over here we observe that its direction is something like this, and over here its direction is something like this. This is the force exerted by the container or by the tube on the liquid, because we identify the change in velocity of liquid. But if you want to find out the value of in question, they are basically asking the liquid exert on the tube, the liquid exert on the tube. So the direction of, according to Newton's third law, for every action there will be an equal and opposite reaction. If the force exerted by the container on the liquid is along this direction, then this will be the force exerted by the liquid on the container, or this will be the direction of force exerted by the liquid on the container. So these are the actual direction of force, which is in blue color. It is the force direction of force exerted by the liquid on the container, and red color it is the force exerted by the container or the tube on the liquid. Now we know that as these two forces are having same magnitude and opposite direction, one thing we can say that the value of net force acting on this one is equal to 0. Now if you are talking about the torque acting on this object, so we can just easily identify what about the value of torque acting on this object. So due to the direction of force over here along this direction and the force along this direction, so we can observe that it will try to rotate this object in anti-clockwise direction. So it will try to rotate this one in anti-clockwise direction because of these two forces. So the direction of rotation will be something like an anti-clockwise direction, because of force acting along this direction and force acting along this direction. Sorry, this is in not in anti-clockwise, it will be in clockwise direction. So direction of sense of rotation is going to be clockwise, not anti-clockwise. So we can say that a clockwise torque is going to act over here.